In May of 1942, the United States Navy sent an undersecretary to a factory on the east side of Cleveland to hand its workers a wartime production award. By the company's own count, the machines built inside that plant went on to turn out more than 90% of the armor-piercing bullet cores fired by American and Canadian forces in the Second World War. 70 years later, federal investigators walked that same floor. The building was packed to the ceiling with garbage, laced with asbestos, and sitting at the center of a criminal case. You're watching the Trade Archive, and this is the story of National Acme. And the story doesn't start in Cleveland. It starts in a small town on the Connecticut River. In 1846, in Windsor, Vermont, a gunsmith and two partners took a federal contract to build 10,000 rifles in a brick armory beside a mill pond. The firm was called Robbins Lawrence, and what happened inside that building changed manufacturing forever. Their machinists became the first to achieve interchangeable parts on a fully practical level. Any lock, any barrel, any trigger assembly from the production line would fit any other rifle of the same model. They delivered roughly 25,000 rifles in the era of the Mexican-American War, sold thousands more to the British during the Crimean War, and in the process helped push the milling machine and the turret lathe into everyday commercial use. Foreign governments sent delegations to Windsor just to see how the Americans did it. The British went home calling it the American System of Manufactures. Keep that armory in mind. It's going to come back into this story 60 years later, and when it does, it will give this company half of its name. The other half comes from Hartford, Connecticut, and from a problem that the American system created for itself. By the 1870s, the country was drowning in demand for small turned metal parts. Screws, studs, nuts, fittings, valve bodies, the little components that held together sewing machines, typewriters, bicycles, and eventually automobiles. Every one of them had to be cut from bar stock on a lathe by hand, one at a time, by a skilled machinist who was expensive and slow. The first man to seriously attack that bottleneck was Christopher Minor Spencer, the same Connecticut inventor whose repeating rifle had armed Union cavalry during the Civil War. In 1873, Spencer patented an automatic turret screw machine, built by bolting a set of rotating cam drums onto a Pratt & Whitney turret lathe. He called the cam drum his brain wheel, and the name was earned. Grooves cut into the drum pushed levers, the levers moved the tools, and the machine fed bar stock, turned it, threaded it, and cut off a finished screw with nobody standing at the controls. In 1876, Spencer helped found the Hartford Machine Screw Company to put the invention to work, and the automatic screw machine was born. But Spencer's machine had a limitation built into its design. It held one bar of metal, one spindle. If a part needed 4 operations, the machine performed them one after another, and the cycle time was the sum of all 4. While the drill was drilling, the turning tool sat idle. While the threading die was threading, everything else waited. For 20 years, that was simply how automatic machining worked. The whole industry accepted the limitation as physics. 2 mechanics in Hartford did not. Edwin C. Henn was a machinist and contractor. His partner, Reinhold Hakewessell, was a toolmaker and draftsman. Sometime in the early 1890s, the two of them started chasing an idea that sounds obvious now and sounded reckless then. Put multiple spindles in one machine, mount them in a rotating carrier, like the cylinder of a revolver, and let the carrier index each bar of metal through a series of tool stations. 4 bars in the machine at once, 4 operations happening at the same time, each on a different bar. Every time the carrier turned, a finished part dropped off. The cycle time collapsed from the sum of all the cuts down to the length of the single longest cut. In 1894, after what one industrial historian described as more than a decade of great difficulties, Henn and Hakewessell built and patented the first successful multiple-spindle automatic lathe. In 1895, with cash loaned by a friend, they founded the Acme Screw Machine Company of Hartford. And then they nearly lost everything. The machine worked. The business didn't. The Acme was complex, expensive, and radically unfamiliar, and shop owners who had spent years learning Spencer-style single-spindle machines were in no hurry to gamble on a four-barreled contraption from two men with no money behind them. By 1897, the Acme Screw Machine Company was buried in debt and running out of road. So Edwin Henn made the decision that saved the enterprise. He sent his brother, A.W. Henn, west to Cleveland, Ohio, to find capital. Cleveland, at the turn of the century, was exactly the right place to knock on doors. Great Lakes shipping, rail lines in every direction, cheap Midwestern steel, and a class of industrial financiers actively looking for the next machine to bet on. A.W. Henn found his backers, and the deal he cut tells you how desperate Hartford had become. The brothers traded 25 of their patented Acme machines for a package of cash and a 50% ownership stake in a new Cleveland firm called the National Manufacturing Company, an operation connected to the national screw and tack interests. National Manufacturing put those 25 machines on its floor and ran them hard, turning out screws and studs at a pace no single spindle shop could touch. The machines stopped being a theory. They became a demonstration, running in public every day at commercial volume. Once the demonstration was undeniable, the two companies stopped pretending to be separate. In 1901, the Hartford inventors and the Cleveland money merged into a single entity, the National Acme Manufacturing Company, and consolidated operations at a plant on Stanton Avenue in Cleveland. Reinhold Hakewessell retired from the firm in 1902, his machine design already out in the world and multiplying. The Henn side of the partnership stayed on, and the company settled into a strange double life. It built the machines, and it also used the machines, selling turned screw products under the Namco name, while its automatics filled order books. By 1914, National Acme ranked among the largest manufacturers in Cleveland. But the men running it had noticed something in their own ledgers. The real money wasn't in selling screws for fractions of a cent. The real money was in selling the machine that made the screws to every factory in the industrialized world. Before that pivot could fully play out, the company made the acquisition that completed its name, which brings the story back to Windsor, Vermont, and to the old Robbins and Lawrence armory beside the mill pond. George O. Gridley was born in 1869 on a farm in Hartford, Connecticut. His route into machine design was anything but direct. He put in time at the Waterbury Button Company, then taught himself stenography, of all things, and used it to land a job as personal secretary to James Hartness, the legendary chief of Jones and Lamson in Springfield, Vermont. Sitting beside Hartness, taking his letters, Gridley absorbed the business of machine tools from the top down. He learned design, he learned management, and he learned how a New England precision shop actually made money. By 1899, he was superintendent of the Windsor Machine Company, operating out of the very armory where interchangeable manufacture had been proven half a century earlier. In 1907, Gridley introduced his own answer to the multi-spindle question, a four-spindle automatic built around a heavy carrier that supported the spindles between two rigid discs on a central shaft. Where the early Acme machines had been clever, the Gridley was brutal. Massive castings, deep rigidity, heavy cuts, and a reputation for running for years without complaint. The Gridley automatic sold worldwide, and it sold directly against Acme's machines. National Acme watched its Vermont competitor with a mix of respect and appetite, and in 1915 it settled the rivalry with a checkbook. National Acme bought the Windsor Machine Company outright, and the combined product line took the name that machinists still say today, Acme-Gridley. Henn and Hakewessell's multi-spindle concept carried on Gridley's iron. George Gridley stayed on to manage the Windsor plant through the First World War, then left in 1921 to start over yet again, founding the Gridley Machine Company in New Britain, Connecticut, which later became part of New Britain Machine. He kept designing until the end of his life and held more than 60 patents. His name outlived every company he worked for, cast into the nameplates of machines that are still cutting steel a century later. Meanwhile, in Cleveland, National Acme committed to its future. In 1916, the firm reincorporated as simply the National Acme Company, exited the screw products business, and bet everything on building and selling the machines themselves. To do it, the company raised one of the great machine tool plants of the era at East 131st Street and Coit Road on Cleveland's east side. The scale of it is hard to overstate: 570,000 square feet of floor. A superintendent who worked there decades later described it as 10 acres under one roof, a plant so large that supervisors drove electric carts between departments. But the machines that came out of that floor are the main character of this entire story. Picture a cast-iron beast the size of a delivery van, squatting on a shop floor slick with cutting oil. At one end, a stack of long steel bars rides in a feed magazine. Each bar passes through a hollow rotating spindle, and the spindles, 4, 6, or 8 of them, are mounted in a huge drum called the spindle carrier. The carrier indexes around like the chamber of a revolver. At every stop, each bar arrives at a different tooling station. One station rough turns the diameter. The next drills. The next forms a shoulder or cuts a thread. At the final station, a cut-off tool slices the finished part free. It drops into the pan, and the collet opens to feed the bar forward for the next cycle. Every station cuts at the same time, on a different bar. So every single index of the carrier delivers one completed part. On simple work, that can mean a finished component every few seconds, hour after hour, shift after shift. And there is not one microprocessor anywhere in the machine. The entire performance is choreographed by cams, the direct descendants of Spencer's brainwheel. Drum cams and disc cams, sometimes 24 or more on a single setup, turn together on shafts and physically play the machine like a music box. A rise on a cam lobe advances a tool slide, a fall retracts it. The timing of every motion, every feed rate, every dwell is ground into steel. Which means that changing the machine from making one part to making another is not a matter of typing a program. It means pulling cams, swapping gears, resetting slides, and retooling every station, a job measured in hours or days and entrusted to the aristocracy of the trade, the setup men. A good setup man carried the whole machine in his head. He knew the feel of every clutch, the lash in every gear train, and the exact clearance where a misjudged tool path would send two slides into each other at full speed, a crash that could snap hardened steel like chalk. He could listen to a 6 spindle at full song and tell you which station was pulling a dull tool, and shops paid these men accordingly, because a machine standing idle between jobs earned nothing. In the shops, these machines earned a reputation that machinists still repeat on forums today. Deafening, filthy, magnificent. One veteran described a multi-spindle as a turret lathe with 6 times the mess, 6 times the noise, and 6 times the speed. Another compared the sound of a bar machine floor to standing inside a thunderstorm made of gears. The machines shook the concrete, threw a fine mist of sulfurized oil into the air, and outproduced anything else on Earth. They also demanded respect, and the plant that built them was staffed accordingly. The East 131st Street Works was not an assembly shed. Former employees describe a workforce that was, in one man's words, 99% machinists, machine operators, and skilled assembly. The company ran its own tool room, its own milling and drill press departments, its own sheet metal shop, its own hydraulic engineering group, even its own print shop, which produced the thick operator manuals that machinists came to know as the Brown Book and the Red Book. The most precise component in the whole machine, the spindle carrier itself, was machined in-house, and it was so central to the product that carrier production was the last work still being done in the Cleveland plant when everything else had gone. The cams were cut in-house too, ground to the profiles that defined each customer's part. In a very real sense, National Acme's product was accuracy itself, cast in iron, cut by its own people, and inspected by the machinists who made it under a shop culture the company called self-inspection. Your name went on your work. The First World War threw that whole system into overdrive. The warring powers needed shell components, fuse bodies, and engine parts in quantities no manual shop could imagine, and multi-spindle automatics were the only machines on the planet that could deliver them. The Windsor, Vermont plant ran around the clock, and the little town beside the armory doubled almost overnight. Immigrant machinists and farmhands poured in faster than Windsor could house them, and the shortage got worse when a workers' clubhouse burned. National Acme's answer still stands on Union Street today. Between 1920 and 1922, the company built the Namco Block, a four-story brick apartment building with 72 units, said to be the largest apartment block in the state of Vermont, and designed for something unusual in an era of grim company dormitories. Families, proper apartments for married machinists with children. The building was placed on the National Register of Historic Places in 1991, and people live in it right now. It is one of the last places on Earth where you can physically touch what this company built that wasn't made of cast iron. But the armistice nearly killed National Acme. The company had expanded plants, piled up material, and staffed for a war that suddenly ended, and the crash in orders left it, in the words of a Vermont industrial historian, in the lurch, overbuilt, and undercapitalized. The firm survived the post-war slump, but Windsor did not survive the Depression. Around 1933, National Acme closed the Vermont operation, ending the armory town's long run at the center of American precision manufacturing. The machines, the drawings, and the work consolidated in Cleveland, where the company rebuilt itself through the 30s under a president named Frederick H. Chapin, an engineer executive who grew the business roughly 300%, and then found himself running one of the most strategically important factories in the United States. Because in 1941, the war came back, and this time, National Acme was ready for it. The Second World War was a war of machined parts. Every aircraft engine, every truck axle, every fuse, every hydraulic fitting, and every single round of ammunition began life as bar stock in somebody's automatic. Acme-Gridleys were already standing on shop floors across the Allied world, and now the company shipped them into ordnance plants as fast as it could build them. Output at National Acme rose, by the company's own account, some 1,100% after the outbreak of the war. And then there is the claim that opens this video, the one the company's historians put at the center of its legacy. More than 90% of all the 30 caliber and 50 caliber armor-piercing bullet cores produced for the United States and Canadian military were made on Acme-Gridley machines. Take the precision of that figure with the caution any company history deserves. But the substance of it is not in dispute. When an American gunner in a B-17 squeezed the trigger, the odds were overwhelming that the hardened steel core of every round leaving those barrels had been turned, formed, and cut off inside a machine born from Henn and Hakewessell's revolver drum idea. On May 23, 1942, the government came to Cleveland to say so out loud. Navy Undersecretary James Forrestal, the future Secretary of Defense, presented National Acme's Wartime Production Excellence Award, with the workforce represented on the platform by Michael Bezovsky, president of Local 19 of the Mechanics Educational Society of America. A Union machinist, standing beside the future head of the American military establishment, accepting the nation's thanks for a factory full of cams and iron. On the same day, across town, a second Cleveland company received the same honor. Hold on to that detail, because that second company is about to walk into this story and merge with it. National Acme came out of the Second World War in the strongest position of its life, and this time management had learned the lesson of 1918. The company redesigned for peacetime before the shooting stopped and rode the post-war boom instead of being crushed by it. The math of the American 50s was the math of the multi-spindle. Every washing machine, every refrigerator, every V8 engine, every lawnmower carburetor was a bucket of small turned parts, and Acme-Gridleys made them by the billion. Spark plug bodies, brake fittings, hydraulic couplings, transmission shafts, the anonymous hardware of the suburban miracle. Nearly all of it fell off the end of a bar machine somewhere. and an enormous share of those bar machines carried a Cleveland nameplate. The company diversified as it grew, and in 1959 it bought Shalco Systems, a California builder of shell and core molding machines for foundries, the equipment that formed the sand cores inside engine blocks. National Acme now touched the casting as well as the cutting. Then, on October 25, 1968, the company made the biggest deal in its history. It merged with its neighbor and fellow War Award winner, the Cleveland Twist Drill Company, and the combined firm took a new name, Acme-Cleveland Corporation. Cleveland Twist Drill deserves a moment of its own because its story is a mirror of Acme's. In 1875, a young man named Jacob D. Cox Sr. borrowed $2,000 from his father to buy a half-interest in a small twist drill operation run by a Mr. C.C. Newton in Dunkirk, New York. The next year, Cox moved the works to Cleveland, later bought Newton out entirely, took on his nephew as a salesman, and built the firm into the largest maker of high-speed drills and reamers in the world. The company's metallurgists developed Momax, a molybdenum-based high-speed steel that freed American toolmaking from its dependence on scarce tungsten, a breakthrough that mattered enormously through the Depression and the war. And Cox's son, Jacob Cox Jr., ran the company as a genuine pioneer of corporate conscience, establishing an employee profit-sharing plan all the way back in 1915 and writing books on wage theory. Two Cleveland institutions, both born in the 1870s and 1890s, both decorated in 1942, now one company under Cleveland Twist Drill's president, Arthur Armstrong. Through the 1970s, Acme Cleveland looked unstoppable. It bought LaSalle Machine Tool in 1972, a Michigan builder of automated engine production lines, and pushed deeper into complete manufacturing systems. By 1980, the corporation stood near the summit of the American machine tool industry. Net sales of $405 million, roughly 6,300 employees. 85 years after two broke mechanics in Hartford traded their machines for survival money, the company they started was one of the largest machine tool builders in the United States. It would never be that big again. What happened over the next 16 years was not a slow fade. It was a collapse, and it started almost immediately. Between 1982 and 1983, American machine tool shipments fell from $5 billion to under $3 billion, the industry's worst stretch since before the war. At the same time, imports surged from about 10% of the American market in 1974 to over 40% a decade later, and the sharp edge of that wave was Japanese CNC. Computer numerical control was everything the Acme-Gridley was not. A CNC lathe could be reprogrammed for a new part in minutes at a keyboard. An Acme-Gridley needed a setup man, a crane, and a day of swapping cams. For enormous production runs, the old iron still won on raw output, and it always would. But American manufacturing was fragmenting into shorter runs and faster changeovers, and Acme Cleveland's management was slow to see that the ground itself was moving. In fiscal 1983, the corporation lost $31.9 million on sales of $164 million. The response was surgery without anesthetic. Under Chief Executive B. Charles Ames, Acme Cleveland cut its workforce from 6,300 to 2,600 in 3 years, closed or consolidated 15 plants, and eliminated well over 1 million square feet of factory floor. The company demanded wage and benefit concessions from the machinists who had built it, and the machinists answered in the only language they had left. Strikes hit the company in 1986 and again in 1989, bitter ones, from workers who had given decades to a firm that now seemed to regard them as a cost line. Executives churned through the front office, and the humiliations were not confined to the shop floor. In its scramble to look modern, the company's LaSalle subsidiary had signed a 1983 contract to deliver a fully automated flexible manufacturing system to Vickers Incorporated, a bet on exactly the computer-integrated future Acme Cleveland kept missing. LaSalle failed to deliver. Vickers sued for $10 million and won, and Acme-Cleveland eventually settled the judgment for $4 million in cash, plus $4.5 million worth of machine tools. The company that had once out-engineered the world was now paying its debts in its own unsold iron. And then came September 6, 1990. On that day, at a plant running an Acme-built spindle machine, an operator named Gordon Hurley was at his post, while a metal rod fed automatically into the machine beside him. A few feet away, a parts inspector named Victor Maldonado was checking finished work. Somewhere in the feed, the spinning rod deformed. Unsupported bar stock whipping at spindle speed stops being a workpiece and becomes something closer to a steel flail, and every machinist who has ever run a bar machine knows the sound it makes. A howl that cuts straight through hearing protection. Maldonado heard that sound, turned, and watched the rod strike Gordon Hurley in the head and kill him where he stood. Maldonado was close enough to touch him. He survived, physically, and then he sued National Acme, and his case went all the way to the Federal Sixth Circuit Court of Appeals, which ruled in 1996 that his claim could go forward. For a century, the ferocious speed of these open, cam-driven machines had been the company's entire selling point. Hurley's death is the permanent reminder of what that speed costs when anything, material, maintenance, or luck, goes wrong. Generations of bar machine operators carry the same lesson in missing fingertips. By the mid-90s, the company itself was dying. In 1995, Acme-Cleveland sold the National Acme machine lines, the actual heart of the original business, to a firm called Devleague Bullard, keeping mostly telecommunications and sensor operations for itself. What remained was a smaller, weaker company wearing a 100-year-old name and on Wall Street that is called Prey. In March of 1996, the Danaher Corporation of Washington, D.C., a conglomerate built on acquiring distressed industrial assets, launched a hostile tender offer at $27 a share, roughly $186 million. Acme-Cleveland's board called the price inadequate and reached for the standard defenses, a shareholder rights plan, the so-called poison pill, and the protections of the Ohio Control Share Acquisition Act. Danaher answered with lawyers, suing in federal court in the Southern District of Ohio to break the defenses open. The siege lasted into the spring. Then Danaher simply raised the price, $30 a share, about $200 million in cash. The board took the deal. The poison pill was dissolved, and on July 2, 1996, shareholders voted the company into Danaher's hands. 101 years after two Hartford mechanics borrowed money from a friend, National Acme's corporate line ended in a tender offer spreadsheet. But the machines refused to die with it. Devleague Bullard kept building at East 131st Street until its own bankruptcy in 1999, and the last spindle carriers were machined in Cleveland in the early 2000s. In 2004, a machine tool builder in Rockford, Illinois called Bourne & Koch bought the assets, and with them the drawings, some dating back to 1896, becoming the official OEM source for Acme-Gridley parts and service. That is not a museum arrangement. Thousands of Acme-Gridleys are running production right now, on shop floors from Ohio to India, some of them more than 80 years old, some retrofitted with modern servo controls, and on the right high-volume job, a well-tuned six-spindle from the Truman administration will still outproduce a brand-new CNC machine costing $1 million. The product outlived the company by design. It was simply built too well to stop. The building was not so lucky. The great plant at East 131st and Coit Road sat abandoned through the 2000s, 10 acres of dark floor and broken glass in a neighborhood that had once set its clocks by the shift whistle. In June of 2011, a businessman named Christopher Gattarello leased the plant, telling the city he would run a paper and cardboard recycling operation there. What he actually did was fill it with garbage. For close to a year, trucks rolled into the old machine works and dumped, until thousands of tons of municipal waste stood floor to ceiling where the spindle carriers had been ground, a rat-infested biological hazard sitting a few hundred feet from homes and an elementary school. The plan was to demolish the building and sell its structural steel for scrap. In July of 2012, a demolition contractor named William Jackson filed paperwork falsely claiming the factory contained no asbestos. The city rejected it. Jackson started tearing the building down anyway. On July 21, 2012, no abatement, no permits, releasing asbestos fibers over the surrounding streets of Cleveland's East Side. The federal government prosecuted both men under the Clean Air Act. In September of 2017, Jackson was sentenced to 33 months in federal prison and ordered to pay $7.8 million in restitution. Gattarello got 57 months and millions more. The factory that had armed the free world ended its working life as evidence in an environmental crime. The land, at least, gets an ending the company never did. In 2024, the Cuyahoga Land Bank won a state brownfield grant of more than $7.5 million, with the city adding its share to push the cleanup past $11 million, the largest demolition the land bank had ever taken on. In April of 2025, officials broke ground. The National Acme site is being scraped clean, its soil purged of asbestos, arsenic, and lead, and joined with the neighboring former Republic Steel property to create a 37-acre shovel-ready industrial site, the largest developable industrial parcel in the city of Cleveland, with new manufacturing jobs promised on the same ground where Edwin Henn's 25 traded machines once proved the whole idea. It all started with two mechanics who could not pay their bills, invented the architecture of mass production, and lost control of it within 6 years. A stenographer from a Connecticut farm put his name on the most durable machine tool ever built in America. The company they left behind armed 2 world wars, housed its workers in the biggest apartment building in Vermont, peaked at $400 million, and was dismantled in a decade and a half by a technology shift its own engineers saw coming and its executives did not. The corporation is gone. The building is gone. The only thing National Acme built that survived is the thing that mattered, the machine itself, still turning bar stock into parts on shop floors all over the world, decades after everyone who profited from it has left the stage. If you want more stories like this one, the next Trade Archive documentary is on your screen right now. We will see you there.